A boat engines down to idle in the middle of Lake of the Woods, where the water opens into a maze of pine-covered granite knolls that stretch past the horizon in every direction. There are no navigational markers here, no clear shorelines, and no obvious main channel. Just thousands of silent, tree-lined landmasses rising out of the water, looking identical to one another under a gray morning sky. Then comes the quiet anomaly that breaks the quiet scene. Despite over 2 centuries of continuous surveying and modern satellite imaging, no official survey has ever produced an exact, definitive count of how many islands exist in this single body of water. What makes this baseline uncertainty remarkable is not merely the maze of the terrain itself, but that the official records simply accepted the ambiguity for generations, relying on loose estimates that varied by thousands depending on where a surveyor drew the line between a reef, an island, and a seasonal rock. How does a fully mapped, heavily traveled interior waterway in a modern nation maintain a physical count that remains technically unresolved to this day? This video examines the hidden geographical anomalies, forgotten survey errors, and overlooked phenomena scattered across Canada's landscape, from shape-shifting island clusters and post-glacial gravitational dips to swallowed towns hidden beneath modern reservoirs. Later in this investigation, we will uncover how a massive 2-billion-year-old impact crater in northern Ontario was misread as a simple volcano for decades, hiding one of the planet's richest metal deposits, and how the physical coast of Hudson Bay is actively rising out of the ocean at a rate fast enough to remap local harbors within a single human lifetime. For generations, the standard assumption held that the geography of the provinces and territories was fixed, fully catalogued, and permanently settled once the initial boundary lines were inked onto parchment. It was a completely reasonable assumption for its era. 19th century hydrographers and geologists traversed thousands of kilometers of wilderness on foot and by canoe, filling in vast blank spaces on official maps with extraordinary skill and endurance. Yet, beneath those neat ink lines lay an unstable ground where shifting water levels, post-glacial rebound, and overlooked geological structures continuously, quietly challenged the completeness of the official record. To understand how these geography anomalies operate, one must first look at how the country's vast expanse was divided and recorded, starting with the outer edges of the Atlantic coast. In Nova Scotia, off the eastern tip of Cape Breton Island, sits Scatterray Island, an isolated, fog-bound granite outpost protecting the approaches to Mira Bay. Covering roughly 2,700 hectares, this unpopulated reserve was once home to lightkeepers and seasonal fishermen who braved some of the most treacherous waters on the eastern seaboard. What made Scatterray an anomaly was not just its thick fog, but its position as a graveyard for shipping, where shifting currents led dozens of vessels into its jagged shoals. Today, it stands as a strictly protected wilderness area under provincial law, completely empty of human life, where dense balsam fir forests slowly swallow the stone foundations of long-abandoned fishing stations. Moving inland to Prince Edward Island, the tiny landmass of Baird's Island sits isolated in the middle of the Brudenell River within Kings County. Covering just a few hectares of marsh and red sandstone, it represents a landform shaped entirely by dynamic estuarine tides. For decades, local farmers used the river's ice bridges in winter to move livestock, but as modern causeways altered local water currents, the island became completely cut off from mainland access. It remains entirely unpopulated, serving as a quiet sanctuary for migratory waterfowl, while its soft sandstone edges are steadily carved away by saltwater every year. In New Brunswick, within Charlotte County, Grand Manan Island guards the mouth of the Bay of Fundy. While Grand Manan itself supports a permanent population, its outer satellite, Machias Seal Island, holds a distinct administrative and geopolitical secret. Sitting roughly 20 kilometers off the coast, this tiny, tree-free rock of less than 10 hectares supports a historic lighthouse operated continuously by the Canadian Coast Guard since 1832. Because the surrounding sea sits within the disputed gray zone between Canada and the United States, Canada maintains a permanent footprint on the island to enforce sovereignty, making the lightkeeper the only resident on an island surrounded by contested fishing grounds. The island doubles as an intense wildlife sanctuary, hosting thousands of Atlantic puffins that nest in the rocky crevices, while armed state and federal patrol boats navigate the turbulent tides just offshore. In Quebec, deep within the Le Domaine du Roi regional county municipality, sits the deserted mill town of Val-Jalbert. Founded in 1901 near the mouth of the Wiachuan River, the settlement flourished briefly around a mechanical pulp mill powered by the 72-meter Wiachuan Falls. When the mill permanently shuttered in 1927 due to shifting paper markets, over 500 residents packed their belongings and walked away. The provincial government eventually converted the property into a heritage park, preserving dozens of wooden company houses, streetlights, and industrial structures completely intact. The town stands as a frozen snapshot of early 20th century industrial expansion, where a modern visitor can still walk down empty streets where forest is slowly creeping back through the boardwalks. In Ontario, buried beneath the surface of the upper St. Lawrence River, lie the Lost Villages. 10 entire communities flooded in July 1958 during the construction of the St. Lawrence Seaway and Hydroelectric Project. To build the Moses Saunders Power Dam and create Lake St. Lawrence, engineers inundated over 20,000 hectares of farmland, relocating roughly 6,500 people and moving hundreds of homes on massive flatbed trailers. Today, off the shoreline of Stormont, Dundas, and Glengarry, the submerged foundations of Altsville, Farrens Point, and Dickinson's Landing lie beneath 5 to 10 meters of water. On clear days, boaters can look straight down through the river to see intact asphalt stretches of Old Highway 2, concrete bridge abutments, and sidewalk outlines resting undisturbed on the riverbed. In Manitoba, isolated within the Division No. 19 unorganized territory in Lake Winnipeg, lies Matheson Island. Located in the Narrows where the lake's northern and southern basins meet, this 500-hectare landmass has been inhabited by Indigenous families and Métis commercial fishers for generations. For decades, the community operated without any land link to the mainland, relying entirely on winter ice roads or a seasonal cable ferry crossing a 200-meter channel. The surrounding waters sit directly over ancient Ordovician limestone strata, where storm surges frequently shift shallow sandbars and alter shoreline geometry, continuously reshaping the narrow channels that local fishing vessels must navigate to reach the open lake. In Saskatchewan, deep within the boreal forest of Northern Saskatchewan Administration District, lies Cracking Stone Point and its surrounding lake islands along the northern shore of Lake Athabasca. In 1946, prospectors working for the Crown Corporation Eldorado Mining and Refining discovered rich pitchblende deposits nearby, triggering the 1950s Canadian uranium rush. The surrounding archipelago, formed by ancient Precambrian shield granite carved by Laurentide ice sheets, held high-grade ore deposits buried beneath thin glacial drift. While the nearby mining center of Gunner was abandoned in 1964, leaving behind open pits and millions of tons of mine tailings, the unpopulated granite islands surrounding the peninsula remain strictly monitored by Natural Resources Canada for radioactive runoff and structural stability. In Alberta, inside Municipal District of Bighorn No. 8, the waters of Abraham Lake submerge a drowned mountain valley along the North Saskatchewan River. Created in 1972 by the construction of the Bighorn Dam, the 33-kilometer-long artificial reservoir flooded historic river flats long traveled by Stoney Nakoda hunters and early fur traders. Beneath the surface lie flooded timber stands and gravel riverbeds, but the reservoir's defining geological phenomenon occurs every winter. Decaying vegetation on the lake floor releases massive volumes of trapped methane gas. As the water freezes, millions of white gas bubbles become frozen in stack formations inside the clear ice, creating a visually striking display that draws glaciologists and geologists studying natural greenhouse gas emissions from flooded northern reservoirs. In British Columbia, within the Squamish-Lillooet Regional District, Lake Garibaldi sits 3,000 meters above sea level, held in place by a massive, unstable geological barrier known as the Barrier. Roughly 9,000 years ago, a massive lava flow from the Price Bay volcanic vent dammed the local valley, creating a natural volcanic rock wall over 200 meters high that holds back the lake. In 1855, a massive section of the lava cliff collapsed, shedding 30 million cubic meters of rock into the valley below. Because geological surveys conducted by the Geological Survey of Canada confirmed that the remaining rock wall is prone to cataclysmic failure, the province declared the area directly below the lake an uninhabited hazard zone in 1980, forcing the relocation of local residents and leaving the fragile rock wall under continuous seismic monitoring. In the Yukon, tucked inside the Kluane region, lies Boundary Island in the middle of Kluane Lake. Formed by sediment dropped by the retreating Kaskawolsh Glacier, the island's coastline shifted violently in 2016 due to a rare geomorphological event known as river piracy. Over just a few spring days, melting from the retreating glacier redirected the lake's primary water source away from the Yukon River drainage basin and into the Gulf of Alaska via the Alsek River, causing Kluane Lake's water level to drop by over 2 meters in a single season. The sudden drop exposed hundreds of meters of mudflats around the island, stranding docks and altering the local shoreline so rapidly that nautical charts had to be completely withdrawn and redrawn. In the Northwest Territories, deep within the Inuvialuit settlement region, Garry Island sits in the outer Beaufort Sea at the mouth of the Mackenzie River Delta. Composed of ice-rich permafrost and fine glacioval sediments, the island was a critical historical whaling camp for Inuvialuit families who navigated these northern waters for centuries. Geologists from the Geological Survey of Canada have monitored Garry Island for decades because its sea cliffs are actively collapsing into the ocean at rates exceeding 2 meters per year due to thermal erosion and warming sea temperatures. As the frozen ground thaws, massive retrogressive thaw slumps carve away the landmass, eroding ancient archaeological deposits directly into the sea. In Nunavut, near the eastern entrance to the Northwest Passage in the Qikiqtaaluk region, lies Beechey Island, a small, barren coastal peninsula of Devon Island. It served as the winter quarters for Sir John Franklin's ill-fated Arctic expedition in 1845, before all 129 men vanished into the ice. The island holds 3 marked graves from that winter, preserved in the permafrost alongside hundreds of discarded tin cans that provided early evidence of lead poisoning among the crew. Beyond its bleak human history, Beechey Island sits on a raised beach sequence formed by rapid post-glacial rebound, where the land has risen tens of meters out of the ocean since the ice sheets melted, leaving ancient shoreline gravel terraces perched high above the current sea level. What connects all these geographical anomalies across 13 provinces and territories is not merely their extreme physical isolation, but the precise scientific instruments that were eventually developed to explain them. Instruments that began revealing unexpected physical forces operating right beneath the Earth's crust. In Ontario, the true nature of the Sudbury Basin remained misunderstood for generations, despite being one of the world's most productive mining districts. Geologists in the late 19th century assumed the 60-kilometer-long oval structure in northern Ontario was formed by ancient volcanic activity, a logical deduction given the abundant igneous rock formations. That consensus held until 1964, when geologist Robert Dietz applied shatter cone analysis, examining distinct conical fracture patterns in the rock that only form under extreme, instantaneous shock pressures exceeding 2 gigapascals. Subsequent drill core samples recovered by the Geological Survey of Canada confirmed the presence of shocked quartz crystals and thick impact breccia, proving the entire basin was actually a massive impact crater created 1.85 billion years ago when a meteorite 10 kilometers wide slammed into the Canadian Shield. The impact fractured the Earth's crust so deeply that heavy nickel-copper-platinum magmas welled up from the mantle, concentrating billions of dollars of ore along the crater's rim that had been misread as simple lava flows for 80 years. Further north in Quebec, the Manicouagan Reservoir presents a similar history of delayed scientific recognition. Covering nearly 2,000 square kilometers in the Côte-Nord region, this circular lake was long assumed to be a conventional ring of glacial valleys surrounding a central mountain peak, Mount Babel. When Hydro-Quebec dammed the Manicouagan and Mouchelaguain rivers in 1968 for the Daniel Johnson Dam, the rising reservoir filled the circular trough, creating a striking ring-shaped lake clearly visible from orbit. But it was airborne magnetic surveys and petrographic thin-section analysis conducted by Canadian geoscientists that proved the site's true origin. The ring was a 214-million-year-old impact crater, one of the oldest and largest preserved on Earth. Isotope dating of melt rock recovered from Mount Babel showed the central peak was actually the rebound dome, formed when the Earth's crust snapped back upward immediately after the impact. In the Northwest Territories, the discovery of the Lac de Gras diamond fields in 1991 systematically dismantled decades of geological consensus through methodical indicator mineral sampling. The prevailing industry belief held that the Canadian Shield was too geologically disturbed to preserve diamond-bearing kimberlite pipes. Geologists Chuck Fipke and Stuart Blusen spent over a decade tracing microscopic heavy minerals, specifically pyrope garnets, chrome diopsides, and ilmenites, across hundreds of kilometers of subarctic tundra. By analyzing the chemistry of these indicator minerals using electron microprobe technology, Fipke tracked the glacial dispersion trail backward against the flow direction of ancient Laurentide ice sheets, culminating in the extraction of diamond-rich drill core beneath Point Lake in late 1991. The discovery opened a vast mining district in ground previously dismissed as barren wilderness. In Nova Scotia, Sable Island, a narrow 34-kilometer crescent of sand lying 300 kilometers offshore in the Atlantic Ocean, defied early cartographers due to its constant physical movement. Known as the Graveyard of the Atlantic for causing over 300 recorded shipwrecks, the island was long depicted on Admiralty charts as a fixed navigational hazard. However, repetitive aerial photographic surveys and satellite laser altimetry conducted by Environment and Climate Change Canada revealed that Sable Island is not static at all. It is an active, migrating sandbar moving eastward at roughly 100 meters per century. Driven by powerful North Atlantic winter storms, longshore drift, and deep ocean currents, the island continually erodes on its western tip while accumulating sand on its eastern end, shifting its position faster than historical survey maps could be published. Yet, understanding how shifting sands, ancient meteorite impacts, and hidden ore bodies were pinpointed through modern instruments raises a deeper, more immediate question. What happens to the human communities when these dynamic geological realities and hydroelectric transformations collide with the permanent layout of modern towns? The present-day consequences of these dynamic landforms and submerged histories directly shape modern infrastructure, municipal budgets, and daily life across Canada. Around Hudson Bay, post-glacial rebound is actively altering coastal geography at an average rate of roughly 1 centimeter per year, or a full meter per century. In communities like Churchill, Manitoba, and Moosonee, Ontario, this ongoing uplift forces hydrographic teams from the Canadian Hydrographic Service to continually resurvey navigation channels as shallow harbor basins gradually lift toward the surface, stranding old marine slips and changing water depths for commercial shipping vessels. What was once deep water during the era of early fur trade posts is now emerging as fresh mudflats and rocky reefs, requiring constant adjustments to nautical charts and port infrastructure. In northern urban centers built directly over major geological anomalies, the legacy of early mapping decisions carries immense economic weight. In the city of Greater Sudbury, over a century of intensive underground mining along the rim of the ancient impact crater has left hundreds of kilometers of subterranean shafts and stopes beneath the modern municipality. Mining companies like Vale Canada and Glencore spend tens of millions of Canadian dollars annually on deep seismic monitoring networks, backfilling operations, and structural engineering to prevent rock bursts and surface subsidence. The very impact structure that created the region's mineral wealth now demands continuous geotechnical intervention to ensure the safety of roads, utility corridors, and residential neighborhoods constructed directly above active mine workings. Along the upper St. Lawrence River, the submerged footprint of the lost villages presents ongoing navigational, environmental, and engineering considerations. Hydroelectric Power Commission of Ontario planners in 1958 intentionally flooded thousands of structures, but many stone foundations, roadbeds, and submerged canal locks remain intact beneath Lake St. Lawrence. Parks Commission authorities and marine safety inspectors monitor these shallow underwater ruins, which draw recreational scuba divers while posing unexpected hazards for deep-draft commercial freighter traffic operating within the Seaway Channel. Modern water level regulation, managed by the International St. Lawrence River Board of Control, must balance commercial shipping draft requirements, shore erosion protection, and power generation against the permanent physical presence of the flooded 19th-century towns resting below. Further north in the Northwest Territories, the thawing of permafrost landscapes, such as those surrounding Garry Island and the Beaufort Sea coastline, has triggered immediate structural consequences for northern communities. Natural Resources Canada estimates that climate-driven thermal erosion along northern coasts is causing shoreline retreat rates of up to 2 to 5 meters annually in high-risk zones, washing away cultural heritage sites and forcing local authorities to evaluate costly coastal defense projects or community relocations. Ground subsidence caused by melting underground ice lenses damages roads, airport runways, and building foundations across the Arctic, turning what was once considered permanently frozen ground into a constantly shifting engineering challenge that requires specialized thermosiphon cooling systems embedded into building foundations. These active physical transformations across the provinces and territories demonstrate that the map of Canada is far from static, driven continuously by deep geological forces and post-glacial adjustments. Yet, as satellite monitoring and precision geodetic surveys continue to map these shifting landscapes, one final, fundamental geographical question remains to be answered. That question brings us back to Lake of the Woods in northwestern Ontario, where the fundamental problem of counting and cataloging an intricate landscape remains unresolved. For over a century, local folklore and official tourist guides have repeated the figure of 14,552 islands across the lake's 4,300 square kilometers of surface water. But hydrographers at the Canadian Hydrographic Service and survey specialists at Natural Resources Canada acknowledge that this famous number is actually an administrative convention rather than a definitive physical count. Depending on whether a survey uses high water or low water baselines, whether a rock exposed only during autumn drawdowns is classified as a reef or an island, and where the boundary between an islet and a rocky shoal is drawn, the true count shifts by thousands. In the Kenora district, where Lake of the Woods spans the borders of Ontario, Manitoba, and Minnesota, early hydrographic charts relied on manual visual surveys and lead line soundings that could never capture every granite outcrop pushing through the water. Modern satellite imagery and airborne LiDAR bathymetry have only exposed the limits of those early maps, revealing thousands of micro-islands and dynamic sandbars that emerge and submerge with seasonal flow variations. What was treated for decades as a simple, fixed geography is in reality an ever-shifting archipelagic network where no two government databases agree on the exact tally of landmasses. What kept these physical realities obscured for so long was not a failure of courage or effort by early cartographers, but a fundamental assumption embedded in traditional survey practice: the belief that a boundary line drawn on paper permanently freezes a landscape that is actively moving, rebounding, and eroding beneath our feet. What remained thin was never the physical reality of the land, nor the deep geographical knowledge of the First Nations who traveled these waterways for millennia, but the official record's capacity to measure forces operating across millions of square kilometers and thousands of years. Even today, vast sections of the Arctic archipelago, the deep interior of the Canadian Shield, and dynamic coastal zones are monitored through real-time satellite altimetry because the ground refuses to remain static. Geophysicists continue to measure the precise rate of post-glacial rebound around Hudson Bay. Glaciologists track the exposure of ancient organic materials from melting Yukon ice patches, and hydrographers continuously adjust navigation routes along changing northern rivers. The official map presents the appearance of a finished surface, yet the physical Earth below it continues its slow, unceasing transformation. Which geographical anomaly or submerged site in your own province or territory has always struck you as the most overlooked? Or which location in this investigation surprised you most? Share your thoughts in the comments below and consider subscribing to join us for our next geographical